Hello, it is the 1st of December, and that means it's time to do some advents of code. I do them in Rust. Now, I have built some tooling to make getting these set up nice and quick and easy. So this is going to add a new, and you can see my previous solutions here. This isn't all my previous solutions. I built the new tooling recently, and I'm currently in the process of porting everything over. But while my scaffolder runs in the background and builds my new one, let's have a read. Prelude, you need to get stars, collect stars. Submarine drops below the surface of the ocean. It automatically performs a sonar sweep of the nearby ocean floor. We have numbers on lines. On a small screen, the sonar sweep report appears. Each line is a measurement of the seafloor depth as the sweep looks further and further away from the submarine. This report indicates that scanning outward from the submarine, the sonar sweep found depths of... Okay. First order of business to figure out how quickly the depth increases. Just so you know what you're dealing with, you never know if the keys will get carried into deeper water by an ocean current or a fish or something. I'm guessing... the sleigh keys are in the ocean. Cool. To do this, count the number of times a depth measurement increases from the previous measurement. There is no measurement before the first measurement. The changes are as follows: increased, increased, decreased, increased, 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 decreased, increased. In this example, there are 7 measurements that are larger than the previous. How many measurements are larger than the previous measurement? Should be nice and easy to do. And we should have our input here. Okie dokie. I need to fix that. I'm going to just quickly make sure that my my session token is valid. Should be. I will have to do that off screen for my own, privacy reasons. Cookies for advent of code. I am not okay. I guess I need to log myself back in. Go. Now I'm logged in. I should have a nice session cookie I can steal. Indeed. Grab that. There. Save that. Close that and never show it on stream. And for now, I will manually input my puzzle input, but for future ones, this should get downloaded for me automatically. So, let's go back in for this puzzle here. So, just to give you an idea of how this works, my scaffold basically sets up a pass function and 2 task functions. Our passed input here is going to be depths, which are going to be a vector of... These are all positive. These are all positive. I'm just going to make some I32s for convenience, though. They can actually be smaller than that. They all seem to be quite 4-digit numbers. Yeah, but... whatever, we'll overprocess a little bit. Okay, and so to get this, we are going to need a few passes. We are going to need car complete I32. We are going to need line ending. We're going to need sequence, multi-separated list. And that should be all of the things we need, except for line ending doesn't exist. What's line ending called? Statistically, it's going to be on one of these that I click on. Character complete line ending. That'll do it. Line ending, okay. So our parser can be, in theory, separated list of line ending I32, and that should be our entire parser. So that should, in theory, okay, I also need to do combinator map, and then we can say let numbers is this, let me pass is map numbers depths passed input with depths. And so that will give us our passed inputs, and we can check that that works by just coming in here and debug printing our input depths. And we can test that by doing cargo run bin run on 21 day 1, and that should it wants a ampersand here. Run cargo run bin util. There we go. And so that's going to build this, and it's going to run task 1, which right now just prints out the all of our depths, and this is just going to check that we're passing our input correctly. I'm pretty confident that we are, so let's just see. Rust compiler, always a joy to work with, nice and slow. Technically it is compiling a load of things that I don't need it to compile, but you know, we'll there we go, yeah. So that's all of our inputs. Cool. Now we need to count the number of times it strictly increases. So what we're going to do is we are going to say that our output is going to be a usize, because we're going to count. We're going to do input.depth.iter.tuple tuple windows .map ab .filter even. And we only care about the cases where b is greater than a, and then we count those. And that should be task 1. Now we can write a test for this because they give us a helpful test case. So what we can do is we can come in here and we can say test or assert task, I think is the macro that I wrote. Pass task 1. And let's just manually new line separate these so that it all fits on one line. And we can run this test and hopefully passes. So that one ran correctly. So now what we should be able to do is run our task on our actual input, and we get the number 1266, which for my input is correct. Continue to part 2. Okay. Considering every single measurement isn't as useful as you'd expected, there's just too much noise in the data. Instead, consider sums of a 3-measurement sliding window. Again, considering the above example, A, B, C, D. Oh, okay, whatever. Start by comparing the first and second 3 measurement windows. The measurements in the first window are marked A, 199, 200, 208, and B is 200, 208. Yep. 607, 618, it's larger than the sum of the first. Okay, so now what we need to do is a simple filter map. So input, this is also going to be a usize because we care about the number of these. Input.depth.iter.tuple windows.filter, and we are going to filter A, B, C. And we're going to do A plus B. No, we're not filtering, we are mapping actually to start with. So we're going to map ABC into A plus B plus C, and then we're going to call tuple windows on that, and then we're going to map AB. We're going to filter AB where B is greater than A, and then we are going to count all of those. And that should be task 2. Now, do we have a test case for task 2? There are 5. So what we can do is we can say let input equal this thing. Set this to input. Assert task 2, input 5. Let's run our tests. It's just a variable called input, not a constant. And our tests pass. Okie dokie. So now let us run our binary and see what our output for part 2 is. Our output for part 2 is 1217. Is that correct? Yes, it is. And so that is Advent of Code Day 1 done in Rust. Thank you for watching.